All right, so for 1.4, we're just going to cruise really quickly through this first part because it's on vertical asymptotes and limits that go to infinity, so it's pretty straightforward. But on these two graphs, you can see I've got both two graphs that have a vertical asymptote. Just be careful how you answer the questions when you come up to an asymptote, because if you come up from one side, in this case the left and letter A, and in this case the right, you don't put D and E, you put the infinity to which it's going. So you have to go to the infinities on an asymptote, a vertical asymptote. But from the left, you can see this is going to negative infinity, so we put that. From the right, we're going to positive infinity. And then we put a true D and E from both directions, because they're going to different infinities or they're split. This guy over here we call the volcano graph. It happens when you get that squaring in the denominator. And again, from the left, I'm going to infinity. From the right, it's shooting up to infinity. And so therefore, from both sides, this is a situation where I don't write D and E. I write that it's got an infinite limit. All right? So just a little bit with notation. So it says that these limits that produce infinity or negative infinity, say about the function, it says that they have a vertical asymptote at that value of C. So pretty straightforward, nothing earth-shattering there. So that went really fast. And then you should know this already from your Algebra 2 and pre-calc days, that when you write equations for vertical asymptotes, you focus on that denominator, you factor everything. We look in the denominator, and then the x values that make the denominator 0 after canceling provide us with our vertical asymptotes. So on this one, nothing's going to cancel at the top, so we have two of them. They are equations, so be careful of that. Like if it's an FRQ and it says to find the vertical asymptotes, if you just put -1 and 1, you don't earn the full credit. They are lines. So you have to write x equals, you can put plus or minus 1 and kind of kill them off at the same time. So again, nothing really new there. So I'm going fast through the old stuff and I'll slow down through the new stuff. So again, vertical asymptotes are determined by the factors on the denominator. They have to not cancel with a factor in the numerator. Mr. Evanson, when they do cancel, what does that tell me about the graph? Yeah, there's a hole there, the limit exists, and there's a discontinuity. So a lot of stuff you guys should be able to tell me about graphs without seeing them. So I have a hole at 2, 6, 4, 3 halves, right? And I have a removable discontinuity. Makes sense, right? You get why it's removable, right? Just plug the hole up. I have a vertical asymptote at x equals -2, and that's all it asks me for. All right? So again, when you're looking for those vertical asymptotes, easy peasy. Letter A, what's the equation of my vertical asymptote? X equals 1. Letter B has an infinite amount of vertical asymptotes, so we have to figure out how to write that because it didn't specify a domain. So my vertical asymptotes would be where that denominator equals 0. So I travel around my unit circle and I say that that occurs at 0 for sure. So x equals 0 would give me 1, and then pi, and then 2 pi, and then another half turn to 3 pi, 4 pi, 5 pi, 6 pi. It's going to cycle, so a lot of times you'll see it x equals n pi. And then it might say where n equals 0, 1, 2, 3, or n's an element of the whole numbers, that kind of stuff. But that guy has a lot of them. Alright, so the next part, it says, find each limit to the best of your ability without looking at a graph, without seeing a graph. So the minute you look at this, you plug the 1 in, you go, oh, I'm getting 1 over 0. That indicates vertical asymptote, correct? There's only 3 possible answers for hitting a vertical asymptote. You're either heading to infinity, right? Negative infinity, or does not exist, correct? But when it's a one-sided one, it's either infinity or negative infinity. So I don't really care if you make a table. You just have to do some sign analysis. So go ahead and write this down before you decide which infinity it goes to. No matter how many factors there are, you would have to do a sign analysis. So on this simple one, I'm coming in as x is approaching 1 to the left of 1. So if I were you, I'd just go directly to the left of 1. I wouldn't even make a whole table, because your answer is either infinity or negative infinity. So in my head, I'm thinking 0.99, right? Will that result in a positive or a negative number? Negative, correct? If I plugged it in, if I said, well, I'm going to let x be 0.99, I'd have 1 over 0.01, which is 1 over 1/100, which is 100. I'm positive. Even if I got closer, it's going to add a 0. And if I get closer, it's going to add another 0. What am I 100% sure this guy's going to? Infinity, correct? I don't really need a table. I just do what I call be a creeper. So this one is going to be, oh, that's negative. Hello. Should have corrected me, kids. Right, were you thinking that? Hopefully. Right? So this guy's going to be negative infinity. This one, when I come in at from the right, like 1.01, 1.001, 1.0001, that's going to go to positive infinity. So they're going to split. Does that make sense? So just kind of creep in and see which infinity you go to. And I think that that is the end of the first part of my notes and the pauses. Those of you at home, we're going to work on 1.14 worksheet for about 10 minutes, and then we're going to come back and start 1.15. So we're looking at number 4 on 1.14, and we're coming in at 5 from both directions. We will not have a calculator on us. So we're going to hop on there, and we're not going to drop the limit. We're just going to go ahead and keep some decent notation for a little bit. You can actually be a tinge sloppy on this worksheet using this kind of. All right. So nothing cancels, which means no hole in the graph, but I have 2 asymptotes, correct? I'm approaching the one at x equals 5 from both directions. So again, in your brain, you're choosing 2 numbers because we're coming in from both directions. In my head, I'm thinking about 5.001. I'm going to do sign analysis. And what else am I kind of thinking? 4 point what? Some 9s. And I'm just looking at signs, but I'm looking at all 3 of these factors. So at 5.001, positive, positive, positive. What did I just confirm? From the right, I'm shooting up, correct? From the left, it's going to go positive, but then this one's going negative, and that one's positive. What do I put for my answer? DME. Does that make sense? So you're basically going to be what I call a creeper. Maybe from one side, maybe from both, and you really only need, you don't need a full table of numbers. If you know you're going to positive or negative infinity, for sure, you just need it. So the next topic in 1.15 deals with the other things with infinity and asymptotes. And so ion decimals have this function, this function right here, I have it graphed. Here's tabularly what's happening, a screenshot what a table on a calculator would look like. And it appears that as I go to infinity or forever to the right, my y values are settling at 3. And when I go forever to the left, my y values appear to be settling at 3. The graph of that function, just so you can see what it looks like, because the table doesn't give you as good of a story on it. So when I go take a look at my graph of that function right here, you can see that as I ride along and send x bigger and bigger and bigger, I am bound by 3 to the right, correct? And when I head to negative infinity from the left, I'm also up at 3. So when we head to the infinities and we get our limits, it actually provides us with the horizontal asymptotes of the graph. So vertical are based on the denominator equaling 0, correct? Horizontal is what's happening as you send x forever to the left and forever to the right. If it is truly bound, you have a horizontal asymptote. But if I were to take the denominator off of this one and turn it into a parabola, then as I go forever to the right on the x, I'm not getting anything bounding my y value. So I'd say there isn't a horizontal asymptote, correct? But the limit is going to where? Infinity. So they're close, but you really got to watch your D and E's. So on this one, the limit as I go to the infinities is infinity. Done. The horizontal asymptotes, though, don't exist. So there's a little difference there. So back to your notes, it says right on that little piece there, it says fill in the blank. There we go. I'm going to go back. It says as x approaches infinity, f of x or my y values seem to be riding along 3. And as I approach negative infinity, they were riding along 3 as well. So what that means is we can write a limit statement. I can say the limit as x approached 3 x approached infinity of the function ended up being 3. This is calculus language, though, for a horizontal asymptote. Does that make sense? So same here, I actually had one horizontal asymptote, and I got it from analyzing both forever to the left and forever to the right. So our limits at infinity, approaching infinity, give us horizontal asymptotes of the graph. If the graph is there, it's easy peasy. You just send x to negative infinity, and this is going forever up. You send this way, and it's going forever up. So I would say the limits for both of those are infinity. What do you think I would say about the horizontal asymptotes? They what? Don't exist. Okay? On the next one, as I approach negative infinity on the left, y's are heading forever up. And on the right, y's are heading forever down. So I do have answers I can write there. Infinity doesn't exist, but it's a refinement. Again, I'd say no horizontal asymptotes for that one. So then, we'll do a similar thing on this one. As I approach negative infinity, I do seem to have a limit of my y values. My y's are sort of riding along before. So you can see how that kind of gives itself to a horizontal asymptote of y equals 4. When I go to positive infinity, this guy seems to be lying on y equals negative 2. Done. If I were to ask you true or false, a function can pass its asymptote. You'd say, I need another word. You know what the word would have to be? Vertical or horizontal, right? Can we pass a vertical asymptote? That's a brick wall, right? But horizontal ones, you can settle if eventually it rides along too. Doesn't matter what happens in here. Remember, you're going up to infinity. So you can have a whole bunch of funk going on here, but if eventually we're riding along 0, that's our horizontal asymptote. Same over here, or our limit. I'm having what appears to be oscillation, but it's doing what we call converge or settling. And if I had a gun in my head on that one, I'd pick 1 as I go to negative infinity. Does that make sense? So you can cross them as long as it eventually settles. This one, though, is a hot mess. I can't quite figure out what it's oscillating, and I can't quite collapse. I think it's actually going to, looks like it's going to keep on riding like that. So what do you think I say this limit is? And the answer is, it doesn't exist. I don't know, it's going up and it's going down. As I go to infinity, I have no clue what's going on. If you remember from another section, we called that oscillation. So we're done. What do you think? Easy peasy mac and cheesy? Alright. The next part, I know I'm going fast today, it's intentional. All this stuff really intuitively makes sense, and you've had some of it in pre-calculus. So as I go over here, as I send x to infinity, where will that fraction go? Right here. Where do you think that's going to go? Where's it going to settle? As x goes to infinity, picture a gigantic, the biggest number in the world you can possibly think of, and then square it. And then do 2 divided by where do you think it's going to go? 0, correct? And it really doesn't even matter how big that power is. That's also 0. And so is that. You might say, how does that work? Because that's actually 2 over x. And as x gets gigantic, that's going to go to 0. Does that make sense? So when you have these overpowering functions on the bottom, we go to 0. So if I were to ask you, what's the limit as I approach infinity of 5, you'd say, well, it's 5. It's the function y equals 5. It's riding up along 5. What's this piece of the difference going to go to, though? 0. So I'm done. It's really just 5 minus 0. And again, it doesn't matter how big the power was on the bottom, it will always overtake the top if it's bigger. So even if you were asked, I remember there was this on one of the AP multiple choice questions. It was like one where it said, pick all the functions that have a limit as x approaches infinity of 0. Would that have been a winner? Yes. So would this. So would this. Right? As long as that bottom is bigger in power. So when I, go over on this page and we evaluate limits at infinity, this you did in pre-calc, it had a different directive to it. It would have said that f of x equals, and it would have said find the horizontal asymptotes. And your pre-calc teacher should have told you a little sort of trick to use based on the powers. Somebody did remember it last hour. Do you remember, Josh? Like how you... What'd you say?
Infinities and the axis.
Oh, so you go like this? Yeah. Okay. And so technically infinity is not a number, and technically you can't plug it in for anything, but you can think it. In that case, what happens? Like, what would your answer be? Do you remember from pre-calc? Okay, great, because you should have 3 different cases. When there's a bigger exponent on bottom, when they're tied, and when there's a bigger one on the top. Now did that trigger it? Now you're nodding, Caitlin, right? Do you remember what the rule was? If the power is bigger on the bottom, what does your gut tell you it's going to go to? 0. Yeah, bigger on bottom goes to 0, just like the bubble. But it makes sense. Do you remember from pre-calc if the powers were tied? Close. What'd you say? Yeah, when they're tied in power, they're the same. Do you remember what it is? You use the constants up front and you reduce them. I think you were told that, but because you didn't know why, you're not remembering it. Correct? So I'm going to show you mathematically why those 3 rules of this one's going to go to 0, this one's going to go to 2/3, this one's going to go to infinity or be unbound. I'm going to show you why that is by doing what often gets done in math. When you're not quite sure what's happening, it's always, whoopsie daisies, it's always legal to multiply by 1. So you have to agree with me that that fraction I just wrote, 1 over x over 1 over x is 1, correct? When I do that, and I distribute it in, watch what happens. You're going to get 2, because the x's are going to cancel, minus, and then you have a 1 over x on the top. This is the exact same fraction. I'm just giving it a facelift. I'm multiplying it by 1 in disguise. Over here, I get a 1 plus 1 over x. Again, I'm distributing that in on the top and the bottom. But what did we just say 1 over infinity is going to go to? 1 over the biggest number you can think of. Where is it going? 0. And same here, 1 over the biggest number you can think of also goes to 0, which is why you'll always get those lead coefficients. You technically, if you were taught this in college, they'd say divide it by everything by the highest power on the bottom. So let's go apply that to letter B here. If I divided everything, technically I'm multiplying by 1 over x squared, but would that be dividing everything by x squared, correct? So I'll write that. If I do that, what I end up with is just a 2, because the x squareds cancel, plus 5 over x squared, and just a 3 plus a 1 over x squared. Do you see why you get to steal those coefficients? what's all the other crap always going to go to in this case? 0, right? So 2/3. Having said that, I'm not going to do the other two the long way. Whenever the bottom overpowers, this is how you can kind of think of it. This and this, in the grand scheme of huge numbers, do nothing. If I told Rose, you just run 2 trillion to the trillionth power dollars, but you better give me one of them. She's like, I don't give a shit. Here, I have one. I've got so much, right? So in the grand scheme of infinity, these little pluses and minuses don't do anything, correct? So I'm really looking at these. One of these cancels out one of those. And what's 2/3x going to go to when x goes to infinity? 0. Do you see why it's 0? Both formally and just sort of loosely. Same over here. These aren't doing really anything to the problem. They aren't. That's really not legal math, but it's common sense math that adding 5, 1, doesn't matter. I'm going to a gazillion to the gazillionth power, right? So technically on this one, when I do my canceling, I end up with a 2 on the top and an x, and there'd be a 3 up. Technically, that's what I'm analyzing, right? As x goes to infinity, where's that thing going? Infinity, right? So that's why this one, its limit would be infinity. It's going up. All right. Are we good? So here's our rules. If the degree on the numerator is less than that in the denominator, which means we're bigger on the bottom, the limit is 0. Right? Then the next one, if the degree is equal to, then the limit is the ratio of those lead numbers, Amelia said, also called coefficients. I think that was you said it, right, Amelia? She remember from last year, she gets to just steal those coefficients. And then if the degree in the numerator is greater, the function doesn't exist. You might say, yeah, we did that in pre-calculus. You did. They were called horizontal asymptotes. In here, there are limits as we approach what? Infinity. Okay? So, on to the next page. Sometimes, this will be our last page of notes. You have to be really, 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 really careful if I'm going to give you a shortcut. Okay, I'm not going to make you do these formally in the long way. I want you just to sort of absorb them with, like, technically as I go to infinity, I'm going to tell you that that -2 is doing nothing and the +1 is doing nothing. The highest powers drive the tree. So you don't even need to look at, and even if there were like 5 terms, grab the highest power in your brain. All right, it's going to lead the function to where it's going to go. So on the top, I'm just going to pretend it's this. Technically, this isn't legal, but it's really good, solid intuition. The bottom has a root 2, and then this is where you have to be careful of what you think the square root of x squared is. It's plus or minus x, which actually means it's its absolute value. If x was a -3, the square root of it squared is 3. Agreed? It's vital that if I'm going to give you a shortcut, you understand that, because it matters with the sign analysis. So, when Mikey Poo looks at this, he goes, oh, these are tied. They are, correct? But you have to be a little bit careful whether you're going to infinity or negative infinity, because they're so similar. Would you agree? I'm going to start this problem as well and show you the difference. So I'm going to go limit as x approaches negative infinity. You're not doing anything. 3x is going to drive the top. You're not doing anything. Root 2, and then the square root of x squared, you're going to drive the bottom. They are tied in both scenarios, right, Chris? Right? To the first, to the first, to the first, to the first. So we steal the lead coefficients, which would lead to the right answer over here. Hey, Caitlin, why didn't I write y equals? Because it's a limit. If I asked you to find the horizontal asymptote, your answer is the same. But what do you have to write? Y equals. Yeah. Over here, watch the difference. As we go to negative infinity, won't the top always be negative, right? The bottom is still positive. So this guy, I do steal those coefficients, but I have to be careful. Because this one would end up being negative. Did I do that too fast, Charles? I think you got it. Keep in mind this rule only holds. This is the biggest mistake. You ready? Watch. Don't write this. Because remember on your test is on all of the sections. And we approached all different things in here, right? What I'll get sometimes, and if it's multiple choice, you're going to feel really good about it. Kids are going to go, oh, the highest power is still the coefficients. The answer is 4/5. What's wrong with that analogy? I could make it that if I just went like, watch. Now it is, right? That rule only holds if you're approaching infinity. So somebody tell me way back from last week, how would you approach this one? What did you say, Rose? Yeah, you'd have to factor it because you're getting 0 over 0. So you have to factor, cancel, replug the 0 in. Excellent. Do you think a lot of kids just circle 4/5 because you mix up the rules? So be 100% sure that you don't apply these rules unless you're approaching infinity. So let's go up here. Now it says find the horizontal asymptotes. Those are your limits as you approach the infinities. Are you ready? They all better go y equals. Because horizontal asymptotes and horizontal lines. But basically now you're calculating limits. Where's this one going to go? As we go to the infinities, because we're going to both, but it doesn't matter. Where's this one going to go? Bigger on bottom goes to what? 0. On the next one. Bigger, bigger, they're tied. Where's this one going to go? Done. Okay. This one, bigger on top. So you have to be careful because there aren't any. So we don't write infinity or anything like that. We write there aren't any or it doesn't exist. There are no horizontal asymptotes. All right, are we good? Did I go too fast with that? Here's your last problem of the day. You're going to try this one. The minute you see this, you need to be taking the limits as you go to infinity, like I showed you that graph. And don't forget, because most kids across the world do, they forget to go to negative infinity as well. So you have to be careful with your pre-calculus being a little too loose of a rule. But you have both infinities, and it matters. I like what I see Miss Kangas doing. She's like, that doesn't matter, regardless of which infinity I'm going to. And she's in the process of rewriting it. I don't know, Rhea, what are you going to put next to this root 2? What did you say? Raya. What are you going to put right next to this root 2? Yes. But when she does that, she's only got half the answer. Because we can have different, the same, just one. I like it. So hopefully, Raya, you're like, oh, this will be positive and positive. So this is just 8 over the square root of 2. True or false, you need to rationalize the denominator. False. No longer. It's out of colleges. It's an outdated skill. It hasn't reached high schools yet. They don't do that anymore. All right? It'll get to the high schools in a few years. All right? Next up, if you leave that, will you earn all the points available? You're shaking your head, Ms. Perfect. Why? What'd you say?
There's no limit. You have to put x equals.
Oh, I forgot the y equals. So yes, that's part of it. You're right, because it did say horizontal asymptote. It really wasn't a limit. I just need to think of that to find it. So great. Why else is the 8 over root 2 not getting full credit? I did head to the left. Remember I showed you that graph? We head to the left and the right. So now you have to do negative infinity. It won't change Raya's reduction over here. She still has that, but somebody tell me how it's going to change the answer. What's it going to become? Negative. Yeah, because the top's going negative and the bottom will always be positive. So there are 2. They're at y equals positive and negative. I will tell you, if you forgot this one, most kids across the world do. But you should. All right, we are done. What's your assignment?